So we're going to be finishing up our chapter on statistics with something we call two-way frequency tables. And early in this chapter, we're working with what we call quantitative data for a single variable. So that's stuff you want to think that we can measure or take a median or a mean of, things like that. Example, weight of baby chicks or number of video-enabled devices. This section, though, works with what we call categorical data. And that data shows how many things surveyed fall into a certain category. So it's more something that you can count, but not something you can really take an average or a median of. We can't take those same measures as before, just going to mean that we're going to have a different way of measuring that. We're going to skip that first example. That's something we'll look at in class, but let's look down at this first table they give us. So all those surveys data contain only one category or interesting, just looking at basically one thing at a time. Usually we're focused on how two categories relate to each other, and they give you a couple examples. So a pretty common one is how gender might affect what profession you choose. Those would be your two variables. Another one that we're going to look at is hair color and if that has a relation with eye color. So again, that's just two categorical data items that we can compare in what we call a two-way frequency table, and we see one right here. So in this example, a class of 20 students records both hair color and eye color, and we capture that in this two-way frequency table. So it looks like there's three types of hair color that we counted, black, blonde, and red, three different eye colors, blue, brown, and green, and we can use that to answer different sorts of questions. First one is how many students had blonde hair and blue eyes. Pretty simple if we know where to look in the table. Again, blonde hair would be this middle column. Blue eyes would be the very first row. So if I want blonde hair and also blue eyes, I would only use this one category, this 4, because that falls under both conditions. So that's blonde hair and blue eyes. So that would be 4 students with that total. And again, if I'm looking for students with just red hair, it would be this last column. I could use any one of those rows, doesn't matter what eye color, blue, brown, or green. Any student with red hair, I can just look down in this bottom total. That would give us 4 students total with red hair. You can either count up the 1 and the 3, but that's what these margins are for. It's going to count up the totals of red, blonde, and black hair, blue, brown, and green hair. And also we notice a total in the corner. If I survey 20 students, I should have 20 total for both categories. And again, that's our answers to both ends up being 4 that are blonde hair and blue eyed, and also 4 that were red haired. Again, just using those two pieces from our table. So now we're going to construct a table that shows what we call joint relative frequencies and marginal relative frequencies from that data that we had from the first table. And to do this, all we're going to do is basically find percentages, or you can think of it as a decimal as well, or a fraction even works. And for example, what do we mean by a frequency is taking that first category from earlier. So let's look back at the top. We had 3 students that had black hair and blue eyes. And if I take that 3 out of the 20 that we surveyed, you can use that to find a decimal or a percentage. So I just did it, that first column as an example. 3 with black hair and blue eyes out of 20 students total. That'd be 15% or 0.15 of our distribution. If I do the same thing with all of my other groups, so for example, if I move down to the next box, 0.25, I got from this number, I got a 5 out of that 20 students. Again, 5 out of 20 is going to give us 0.25. So all we're doing is we're taking that number from the previous table, divide it by 20, and that way we can get it to find a percentage, or in this case, express it as a decimal. So green, this was, I believe, what was that? 0.05 was 1 person out of 20. 1 divided by 20 would give me that total, same thing. 4 divided by 20 would give me 0.2 for the middle column on the top. 1 divided by 20, we get another 0.05. And notice you could do the same thing for the totals off to the side. If I add down for a column, total should be if I add up 0.15, 0.25, and 0.05, should give me that correct total. Blonde, if I add up that category, I get 0.35, and red hair, same thing, I get 0.2. Another thing to notice is that your bottom corner should add up to 1 because, again, 100% represents all of the frequency. So let's look at the next page in terms of how we're going to use a table like this. We'd like to understand associations or trends using that data set and how I would respond to one category if I know that there's going to be a certain given information in a second category. So we're going to use this, for example, to see if there's a connection between eye color and hair color using what we call conditional relative frequencies. So let's look at that first question. I'll go back to that table in a second here. But let's see how we're going to use it to answer a question. What is the conditional relative frequency of having green eyes if you have red hair? So this is like saying what percent of people with red hair would also have green eyes. So for this type of question, we're always going to use the same concept in terms of I look at both categories. I use them as a numerator of a fraction. and I look at my given information and I use that as the denominator of my fraction. So let's go back and see our question. If we look at people that have green eyes also having red hair, so we want the conditional relative frequency of having green eyes if I know they have red hair, we'd put the red hair on the bottom of our fraction. So looking for the number of people with red hair, in this table it looks like that was 4. And if we also want them to have green eyes, that was, again, our category that was both. So green eyes and red hair, it looks like, so green eyes, red hair, looks like that's 3 people. And if I take that 3 out of the 4 with red hair, that's 0.75, or about a 75% chance that you have green eyes if you also have red hair. So next question, same kind of thing. If we're looking for conditional relative frequency this time of having green eyes if you have black hair, again, in this case, the given is that they already have black hair. We want to see if they have green eyes as well. So if I know the given information, I put that on the bottom. I'm looking for a number of people with black hair. Looks like, again, from our table, there's 9 total people with black hair. If we want to see if they also have green eyes, that would be only 1 person out of that 9 that has green eyes and black hair. So if I use that as a fraction, 1 out of 9 for my frequency, that would be 0.11. So about 11% of people with black hair also have green eyes. So we can use that to answer a question about it. Does it appear that having green eyes has a dependency, or at least an association, with having red hair? And based on our last percentages, remember 75% of people with red hair had green eyes, but only 11% of people with black hair had green eyes. We can answer that question. Yeah, it looks like people that have red hair are more likely to have green eyes as well. Because when we did have red hair, more of those people had green eyes than when they had black hair. So that's what we call just using conditional relative frequencies to make a prediction. If they have red hair, probably more likely to have green eyes than if they had black hair. So one last question that we can answer from that table. Is it more likely that a person with black hair has blue eyes, or that a person with blonde hair has brown eyes? And again, we're going to use conditional marginal frequencies to support that. So we just got to pay attention and decide on what's our given information. So our first question, a person with black hair has blue eyes. So if I say a person with black hair, we're assuming that that's the given information. So we want to know that they have black hair to start with. That was 9 total people from our table. And if we want to check that they have blue eyes, again, that was both categories on the top of our fraction. 3 people from that table had black hair and blue eyes. And again, if we're looking at that table, black hair and blue eyes, that was just the very first box there. So that was 3 people with both. So remember, if I put both over the given information, that was 3 out of 9 people. About 33% have blue eyes if they've also had black hair. Next question, what's the likelihood that a person with blonde hair also has brown eyes? So again, given information to start with is that we're looking at blonde-haired people. So from that table, 7 people I think had blonde hair. Just checking again. Yep, 7 people total with blonde hair. And out of those people, we want to see how many had brown eyes. So out of those 7 blonde-haired people, 2 of them also had brown eyes. Using that as our fraction, 2 out of 7, can get another percentage, which would be 0.29 or 29%. So using that to answer our question, see our percentage a little bit higher if they have black hair, so that's what we're going with. More likely that a person with black hair will also have blue eyes compared to somebody with blonde hair having brown eyes. A little bit less likely. So one last table to answer these same types of questions. This table we're given 52 graduating seniors, and we're trying to find out if there's a connection between gender and if they're going to college or not. So there's 2 different questions that you could ask like this, but are pretty closely related. We want to figure out what's more likely, if somebody that's going to college is female or somebody who's female is going to college. And again, pretty similar questions, but based on how they're worded, the order is pretty important. If I look at that first question, somebody going to college is female. Again, the given information is that they're going to college. So on our table, it looks like that was our first row. 29 total people are going to college. So that's what we look at first. And out of those 29 people, if we also need them to be female, that was our 13 out of 29. Using that to get our percentage, that was 0.45 or 45%. If I switch the question around, now if I'm looking at number of females first, so this is looking just at the girls to start with, out of the 22 females, we also want them to go to college again. That was that 13 that are, again, female and going to college. So remember, our given information goes on the bottom of our fraction. That was looking at 22 girls. 13 of them plan on going to college, so 13 out of 22, about 0.59 or 59%. And that way we can answer our more likely question. it's more likely that somebody who is female is going to college. So that was our second fraction.